Okay, so for standard form of quadratics, we've got to get an equation to look like this so we can graph it. And here's the big thing. When we're talking about standard form of quadratics, if it's a function, it's f of x equals, because that's our function form, ax squared plus bx plus c. And again, they also can do y equals ax squared plus bx plus c. So either one of those two, it's still going to be the same thing for this one. That now there's no print, and basically at this point there are no parentheses. So for this part of it, you have to figure out what the vertex is, and then once we've got the vertex, then we'll be able to find everything that goes with this one. So when we're talking about this one, the a and the b and the c values that are here, these are always going to be real numbers. Now, occasionally you may get a fraction mixed in there, but most of the time, if you've got a fraction, it's going to work its way out when you start finding out the numbers and find all the things that's here. All right, here is the big thing of the day. So draw a big giant asterisk here. Okay, and there's two ways that you can find the vertex. I'm not going to show you the hard way because I don't like it. It's pain. It's terrible. It's long, and it's just frustrating. So I'm not even going to show you that. So I'm going to show you the one way that actually works. That's actually pretty easy with this thing. To find the vertex, which again we said it's HK, right? Taking out those two numbers that we had. H is actually really easy to find. H is just going to be, which again is your x value of your vertex. It's going to be negative b over 2a. All right, and this may be a little bit of an overkill, but I'd rather go overkill than underkill. When you plug in your a and your b values, go ahead and put them in parentheses. And again, I know it's a small little thing, but sometimes it's the little things that make all the difference, right? Okay, so to find the x value of your vertex or the h value, really easy. It's negative b over 2a. Take the numbers, you plug it back in. And again, most of the time, there may be an occasional time where it's going to be a fraction, but I'd say 95% of the time we're looking at whole numbers. Just because if we're having to graph these, it's a lot easier to graph. All right, the k value is a little bit more work to it. Because there's not just one easy little thing here. This one, that's a terrible arrow, by the way. You're going to plug in x equals negative b over 2a. So this is kind of like basically we're doing substitution here. We're going to substitute back in the value for x in this case, which is negative b over 2a, into the original equation. Okay, that's it. All right, now for the book notation, because that's what we're doing. When you're doing this through any book for this part of it, when they're going through everything here for the vertex, which again, they're not just going to be H and K because again, now H and K is easy if we've got it in graphic form or vertex form where you can just pull the numbers out. Anytime we're going standard form where it starts like this, they're gonna their notation that they're going to use for the vertex is you're still going to have the negative b over 2a. That part's going to be the same. But instead of them to show how they're taking this negative b over 2a and plugging it back in, they're going to put f of negative b over 2a. So that's going to be our order pair that looks something like that. Okay, and again, that's going to be our h value, and that's going to be our k value. So anytime you see that in the book, when they show you the negative b over 2a and then f of negative b over 2a, that just means they're taking this number, this value they have here, they're going to go back to this function, and they're going to take that x value, plug it back here, and work it out to see what the answer is going to be that's going to be here. Okay, and that's the only thing we're doing today. There's no tricks. It's just, here's some problems. Let's work through it. Let's see what we got, show you all the different options, and then just kind of see what it is. And so that's the only thing that you have to do today is just take numbers and plugging it back in. Okay, now the one thing you want to remember, one thing we're going to actually add in here. So just remember that the a value determines the direction of the graph. So just like we did yesterday, that if the a value was positive, it was opening up. If the a value was negative, it was opening down. Those same things are going to hold true today. So the a value determines the direction of the graph. So if your a is positive, which again, basically that your a is greater than 0, it does that. And if a is negative, it does that. Okay, so that part of it's going to be the same. Still going to have that if you do it this way, your vertex is at the bottom. This would be a minimum value. If it's a less than 0, your vertex is the top. It's a max value. Everything we did yesterday, domain, range, all that stuff is still the exact same thing. Everything that's going through for that part. The one thing we're going to add today that's going to be a little bit of a shortcut that might actually help you graph this thing a little bit quicker. C is the y-intercept. So the A is going to tell you the direction of the graph. The C tells you where it's going to cross the y-axis. So a lot of times if you've got the vertex, you don't have to go back and plug in points, especially if it's fractions like we're doing yesterday. You may not have to go back and plug in points because as long as you've got the C value, you've got another point that's on the graph that you can go back in and graph and just have that part of it there. Okay, so all we're going to do is we're going to give you a problem, and we're going to do like we did yesterday. We're going to figure out what the vertex is, which again is always the key thing. You have to get the vertex first. We're going to figure out what the max or min value is, depending on which way that it's going. We'll do axis of symmetry. We're going to add in the y-intercept today. We're going to graph it. We'll talk about domain and range, and then we'll, everything that we can do for this part of it. So, all right, everybody ready? Everybody take a deep breath. All right, here we go. So here's all the things we're going to do. We're going to find the vertex. Again, either max or min value, depending on which way it goes. Again, we're going to abbreviate axis of symmetry, just called AOS, just because, speeds things up a little bit. Y-intercept. We're going to do the domain and range. One other thing we're going to do. We're going to write the equation in vertex form, and then we're going to graph. Okay, but the good thing is that once we get the vertex, all this stuff back here is the exact same thing we did yesterday. So it's just getting that one extra part together. So this will be a reinforcement of what we did yesterday. If anybody was a little bit fuzzy, where we were, then this will kind of hopefully straighten things up a little bit. All right, so here we go. Let's go with 2x squared plus 8x minus 1. Okay, so let's keep it simple here, right? A is 2, B is 8, C is -1. Okay, so if this was a test question, there's two things that you can get from this without doing anything at all. Our y-intercept is going to be at the C value, so that's going to be at 0, -1. Again, we're going to write it as an ordered pair just to be on the safe side. I know sometimes they may let you just say the y-intercept's at -1, but just so that we're in the habit of seeing it, kind of like we did on the last test, that we'll write this in an ordered pair, because sometimes they let you do this, sometimes they make you do this. So we're going to go ahead and do both. Okay, the other thing is that A in this case is positive, which means the graph would have to look like this. All right, and if the graph looks like this, we know the vertex is at the bottom, which means that's a minimum point. So we already know now we're going to get a minimum. We got the y-intercept because that's the C value. So now we just need to go back and figure out what the vertex is to know what the minimum value will then be to do what we're going to do. Okay. Oh, one other thing we can kind of get here that goes with this one. What's the range going to be? It's going to be y greater or y less than? Arrows are going up, right? Up is greater. So we know the range is going to be y greater than whatever this min value is when we find the vertex there. So up is greater. If the arrows are pointed down, that's going to be less than. Okay, so here's where you have to do a little bit of math. So for your vertex, to get the h value, I need -b over 2a. And again, I know it's a simple little thing, but we're going to, every time you plug in numbers, when you evaluate numbers, I would say every single time, put them in parentheses. Because I've seen people miss this question for the easy thing of they do the minus the b and then they forget one of the negatives. And it throws the whole rest of the problem off. Because after that, everything else is kind of off on this thing. All right, so that's the negative of 8 over 2 times 2. So that's -8 over 4. So the h value is -2. Okay, everybody okay? Again, every time the -b over 2, it's always going to be that simple. Again, you may get a fraction, but even if you get a fraction, it'll work its way out. And more than likely, if you get a fraction, they're probably not going to ask you to graph it, just because it gets a little difficult to graph with fractions. Okay, so once you've got this, now you take this and plug it back into this equation, 2x squared plus 8x minus 1. You're going to plug it in for x here, and you're going to plug it in for x here. Because again, that technically is our x value of our vertex, so that'll kind of get us going here. And that'll be our k value. Okay, and again, every time you plug in a number, put that number in parentheses. And I know sometimes it's overkill to do that, but a lot of times it's not. And then everything else goes out around it, so we got that. Question?
Wouldn't it be also 2 times -2?
Oh, I did. I put an extra negative in there, didn't I? My bad. My bad. Got happy with my negatives. There we go. All right. So first thing is you got to do your exponents. -2 squared is 4. And then after you have that, you can do your multiplication. So we've got 2 times 4 for 8. 8 times -2 is a -16 minus 1. And now you can just go through and just add them or subtract them, whatever the signs tell you to do. 8 minus 16 is negative 8. Minus 1 is a minus or negative 9. Okay, and we've got the vertex. And that's pretty much all the work we've got to do. That's all the work for this equation to get there. Okay, so that was the very first thing we had to have. We've got our vertex at -2, -9. We know it's going to be a minimum. And it's always going to be at the y value. So the min value is going to be at -9. The axis of symmetry is always the x value. We've already got the y-intercept back up here. We had this was at 0, -1, so we've got that one there. If you want to go ahead and write it down, we can. One more time. 0, -1. All right, so we've got the vertex, we've got the max or min value, we've got the axis of symmetry, we've got the y-intercept. We need our domain, which is always -infinity to infinity. Okay. Your range, again, now if we kind of back up for a minute, from the a value, we know this thing's going up, so we know the range has to be y greater than or equal to. And it's still just the max or min value, so it's y greater than or equal to -9. Okay, so we've got domain, we've got range, intercept, max symmetry, max min value.
Can you show where you got the y-intercept from? 0,
Oh, yes, that it's just the c value. So back up here when we're doing this one, whatever the c value is, that's always your y-intercept. Okay, oh, one other thing before we graph. We've got to have this equation in what they call graphing or vertex form. So to do that one, all we're going to do, again, that was what we did yesterday. That was the f of x equals a times x minus h squared plus k. So basically now they're saying take this equation we had and write it like we did yesterday where we had the parentheses. So we're going to take the numbers we've got, we're going to plug it in here to make it look like what we did yesterday. So that would be f of x equals, the a value is the same a value we had here, which was 2. You're going to take the x value, slide over a little bit. Take the x value you've got here. Remember, if we take it out of parentheses, how you change the signs? If you plug it back in, you're also going to change the sign. So change it from a -2 to a +2. And then the k value will stay just like it is.
Can I talk to you for just 1
Sure.
second?
Okay, so the quick graph, and again, we're not going to get like a super detailed graph just because of space and room, and we don't have like a whole x-y axis here. So if we're at -2, -9, we need a lot of room down here. So let's do something like this, I think. All right, what I'm going to do on my scale here, because I'm going to run out of room, I'm going to do this by 2s, 2, 4, 6, 8. It's going to be right at the bottom there, yeah. Okay, so if we go to -2, -9, that's going to be right there. Okay, now, and here's the good thing when we're doing these. If the vertex is off of the x-axis, remember yesterday how we said we could kind of cheat and you could use your a value of 2, kind of sort of like slope to get the next point. That, now again, it only works for the next point and it only works if it's a whole number. We would go up 2 and then right 1 or left, either way. So we're going to go up 2 over 1 to get the next point here. You're going to go up 2 over 1 to get the next point that would be here. But we also know that the y-intercept is at 0, -1. So we've got a point that we don't have to cheat. We can actually just use that point. We can go to -1, which would be here, and we know that point would be on the graph because that's the y-intercept. All right, and our axis of symmetry would be right down the middle here. And again, the good thing about the axis of symmetry is if they happen to make you do one more point, if you know that this is 2 spaces this way, you can also go 2 spaces this way and put a point here, and you've got another point that will be on the graph. Because it's always equidistant. This should be 1 space this way, 1 space this way. And then we connect the dots. And we've got a graph that looks something like that. All right. Everybody all right with that? Question?
I'm confused. Why do we go up 2 over 1?
We said that like with the a value, because the a value is 2, if as long as the a value is a whole number, we can kind of cheat just a little bit and treat that kind of like slope to get the next point there. So. That bottom point should be at -9. Yeah. Okay, so that's so cancel on that one. That's kind of like we did yesterday. As long as this is a whole number, you can cheat, but only if it's a whole number. So if it's a whole number, to get to the next point, you can treat that like slope. So we can go up 2 and over 1 to get the next point, and you can go either direction, left or right, to get those 2 points.
So if it's a fraction, then I just simplify.
If it's a fraction, you have to actually pick numbers on the, like for this one, you'd have to plug in like if this is -2, -9, you'd actually have to take like -1, plug it back into the equation, and then work it out. So you'd actually have to evaluate it and see what the actual answer would be. If it's fractions, whole numbers, you get to cheat, but fractions. So if this was a fraction, what you would have to do way back up here, just kind of get a quick idea of what you would do here. If that was fraction, you'd go back because we've got that the vertex is at x equals -2. So that would be one. You'd have to pick a value around -2. So you'd have to pick like -1. Oh, it's not gonna work. So you'd have to take x equals -1 and plug that -1 value in for x to work that out to see what you would get. So you'd have to do 2 times -1 squared plus 8 times -1 minus 1, and then just evaluate it and work it out from there. Okay. So but that's only if that was a fraction. So if that was a half, the cheat doesn't work. Cheat only works if it's a whole number. If it's fraction, you have to just plug it back in and just see what the answer would be, because that's just the way it would work out there. So, okay. All right. Anybody else got that same thought? Any questions there? What's that? Oh, take it back down. Yeah. Okay. And again, the only other thing I can think of on this one is for the range, they might make you do interval notation. If everything is greater than or equal to -9, it's negative. And again, it's going up. So they might make you do that for the range, possibly. So just kind of be okay that we can go back and forth on those 2 types for the range there. Again, if you know this is the minimum value, you have to start with that as your lowest number, and then you should go to infinity. If that was the max value, you would start at -infinity, and then you'd stop at -9. So again, it's always the lowest number first. So if that's the min value, that would be your lowest number. Okay, so one with a fraction, just so we can see what we got to do here. And we may have to pause. All right, so with a fraction, let's do this, just so we can see that we won't be able to cheat on this one. So for number 2 here, let's do f of x equals 1/2 x squared minus 2x plus 5. Okay, so a is a half, b is -2, and c is 5. And again, we know that's the y-intercept. So right off the bat, without knowing anything, we've got 1 point on this graph that we have. We know that the a value is positive, so we know it has to do that, which means the vertex is at the bottom, so we know it's got a minimum. And by the arrows going up on the graph, we know the values are always going to be going greater than, so it's going to be y, when we talk about the range, it's going to be y greater than or equal to. Okay, so that's the stuff you can get just by looking at it. You ever been in your room and your parents come in and go, "Would you just look at this room? It's filthy in here." And you've been looking at it the whole time, right? And you just go, "Yeah." All the time, right? This is another one of those things. Just look at it. Okay, when you look at it, you can get this stuff out of it, that kind of thing. So. Okay, so again, we've got to get the vertex first. So to get the h value of the vertex, the h is negative b over 2a. And again, just to be on the safe side, when you plug in the a and the b values for the vertex, for the h value of it, put them in parentheses. So that is minus negative 2 over 2 times a half. All right, the good news is, even though we've got this fraction, when you do half of 2, that's 1. Minus the negative means that's a positive 2, so that's 2 over 1. So that's 2. Okay, so for the vertex, we know that the h value is 2. So we're going to take this value of 2, and we're going to plug it back into this equation. So we can see what it's going to be. All right, let's line it up so we can see a little better there.
Mr. Richardson?
Yes.
Wouldn't 2 times 1/2 be 1?
Yes. So on the bottom, we've got 2 times a half for 1. And on the top, we've got minus negative to make that 2. Okay. All right. No, you're good. Okay. So from here, again, it's order of operations. You've got to do the 2 squared first, which is 4. And then once you do the exponents, now you can do your multiplication. You've got half of 4, which is 2. 2 times 2, which is 4. And now we're just going to put all this together. 2 minus 4 is negative 2, plus 5 would be 3. And that's our k value. So that's the second point, or second value of our vertex there. Okay, and again, once you have those two, and take your time on and that's why I say on these that when you're doing these values for a and b and you're plugging these values in, it's overkill to put parentheses around everything. But if you don't get this correct, everything else over here is wrong. So you have to kind of take your time here and not get in a hurry, because once you've got this, everything else is going to spin off this answer. So you've got to make sure this is correct. Okay, so we've got our vertex. Again, axis of symmetry is the x value. So that's x equals 2. We know that the range, no, what was it we had to do next? The max or min value. We know it's a minimum. And that min value is going to be at 3.
Wouldn't the range be y is greater than or equal to 3?
Yep, so when we do the range, that's y greater than or equal to 3. We know domain is always infinity to infinity. So when we do domain, and again, a lot of times on that one, they won't even ask you for the domain just because it's the exact same answer every single time, because it's always negative infinity to infinity if it's a function. What else have we got? We've got the y-intercept was back up here at 0, negative 5. We'll go ahead and put it here just so we got on the list. So we've got the vertex, we've got the axis of symmetry, we've got the max or min value, we've got the range, we've got the y-intercept, we've got the domain. Oh, and then the equation in graphing or vertex form is, again, taking these values for h and k and plug them back into the function. So again, that was going to be f of x equals a times x minus h squared plus k. We're going to plug in this for h and k. Again, whatever the sign is here, we know it's got to be the opposite here. So if we take it in or out, you always change the sign. So it was a positive 2 here. That means it's going to be a negative 2 there. The K value does not change. The only thing we need is the A value, and we're going to get that from the original equation, which was here. The A was a half. So no, this would be a half. Okay. But again, everything spins off of the vertex. So you've got to take your time when you do the negative b over 2a. And again, I know it seems, sometimes it is overkill to put the a and b in parentheses, but it will keep, because again, if this point's off, everything else is off after that, which means everything over here is off because you've got the wrong vertex. So you've got to take your time and make sure that that's all good. Okay, so if we graph this one, vertex is at 2, 3, so we need more room here. All right, so we start to graph it. You'll need a lot of room over here in the top right-hand quadrant in quadrant 1, so let's make sure we've got plenty of room there. All right, so if we go to 2, 3, there's our vertex there. Okay, now the good thing on this one is, and this is where if you're doing this one on Math Excel, because you know the y-intercept is at 0, 5, you don't technically have to plug in a value, but we're going to do it anyway. 1, 2, 3, 4, 5. That would put us here. Okay, and again, they may or may not ask you to draw the axis of symmetry like this. And again, if you've got this y-intercept that we know that's here, if we're going up 2 spaces and over 2 spaces to get here, you can do the same thing here. You can go up 2 and over 2 to get the next point. We'll actually get that down there. And we know the graph would do that. All right, now, but the question was, if we had to pick, let's say that we didn't know what these values were. We didn't have these y-intercepts here. If you have to pick another point to plug in to know how this thing is going to curve, because you always have to have that one extra point, you've got to plug in some number that's going to make this thing work out. You would have to, because we cannot use the cheat of going up 1 over 2 to get to the next number, because if you do that, that's wrong, because if we went up 1 over 2, well, now we got 2 points on top of each other, which would not work for this thing. So if that's a fraction, we cannot do the shortcut. So what you want to do is you want to pick a number that's a multiple of 2 or a factor of 2 to kind of get your next number. We'll go multiples here. So if we're sitting at 2, probably the easy, because if you plug in 3 here and you square it, that's going to be half of 9. That's going to give you a fraction, and we don't want to graph fractions. So if the a value is 1/2, pick a multiple of 2. Because right now we're sitting on 2, so we're going to go over to pick 4 and plug 4 back into this equation and see what it is if we can work it out.
So you just take a random 40?
Pretty much, yeah. If it's a fraction, you know, this one was 1/2 x squared minus 2x plus 5 that we were plugging it back into. If it's a fraction, pick a multiple of this number. So if this had been like 3, it'd probably be better to pick either like 6 or 9. If this had been 5, you would either pick 5 or 10. So you always want to pick, if you can pick that number, that's great. But in this case, 2 was already taken because that was a vertex. So then you go the next multiple of 2, which was 4. So you always want to pick a multiple of this fraction so that this will come out to be a whole number, is really what it comes down to. Okay, so if we did 4 squared, that would be 16. Half of 16 is 8. 2 times 4 is 8. So then we've got 8 minus 8, which is 0. 0 plus 5 would put that point at 0, 5. Oh, sorry. It would be at 5, and we plugged in x equals 4. Yeah, so it would be, order pair would be at 4, 5. Okay, and that's that point that's, and again, my graph is a little bit off, so 4 really should be right here. So if we pick this point at 4, 5, that would be that point that would be there. Okay, so if the a value is a fraction, you have to pick another number to plug into it, just because the fractions will not work for the shortcut. You cannot cheat with a fraction. You have to plug it in and just work it out and do what you can do there. And again, if there's any good thing you can look for on those to kind of go for, whatever this fraction is for the a value that's here, just pick a multiple of that number. So if it's 2, you either pick 2, 4, 6, 8. If this was 3, you pick 3, 6, 9, 12. If it was 4, you pick 4, 8, 12, 16. Just pick a multiple of that number to plug in, and that way you're guaranteed to get a whole number out of this and not get a fraction. Because again, it's hard to graph fractions, but so we try to pick numbers that would avoid the fractions there.